Welcome to Academic Games Equations BaseM. We're going to be learning how to manipulate the base of our number system to beat other people's equations, and it'll be really fun. So BaseM, you can set M as base 8, base 9, base 11, or base 12. Basically what this does, it will change your number system from instead of being base 10 to base 8, base 9, 11, and 12. What this does is, it doesn't affect the ones place very much, but it will definitely affect the tens place, and hundreds place, and thousands. So basically, how we determine it is we'll have, in the ones place, you always have the base to the 0. Base to the 0 is going to be 1. Tens place, base to the 1 is going to be the tens place. Base to 2 is hundredths, base to 3 is 1,000. So for base 10, we're going to have the ones place, the tens place, and the 100ths place, and the 1,000ths place. But what happens when we change it to base 8, base 9, base 11, or base 12? Well, we'll have base to the 0, 8 to the 0, still going to be the ones place. We'll use base 8 as an example. Base to the 1, 8 times 1, 8th place. Base to 2, the 64th place. Base 3, 512th place. Now this gets a little wonky. If any of you are familiar with binary, you'll know how you have to write the numbers out a lot differently, and just like go like 2s, 1s, and 0s. Similar for that, if you want to make the number, if you have the number like, let's say 55 in base 8, 55, but this is base 8, 55, you're going to have the base of the 0's place, which is going to be the 1's place, and you're going to have the base of the 1's place, the 8th place. Now you'll have 5 1s and 5 8s. So you'll have 5 plus 5 times 8, which is 40. So 55 in base 8 is going to be 45. Basically, you can do this with all the other bases. Alright, so another example of what we can do for base 8 is, let's say we have the number 76, everyone's favorite number. So, what would this be? Well, you have a 6 in the 8 to the 0's place, 6 in the 1's place, and you have a 7 in the 8 to the 1's place, 8th's place. So we convert it. 6 times 1, 6. 7 times 8, 56. 62. So 76 equals 62 in base 8. Another thing we have to factor in is that base 8, they all get smaller, but why is that? Well, because we smushed our number system down to smaller. Because in base 10, we have the numbers 0, 1, 2, 3. We have 0 through 9, and that is 10 numbers. So we call it base 10. However, in base 8, we only have 8 numbers in our system. Okay, so we know that in our regular number system, base 10, we're going to have 10 numbers, 0 through 9. But however, in base 8, we're going to have only 0 through 8. And we know how in base 10, as soon as we add 1 to 9, we put 1 over, and that becomes the 1 in the tens place, and the 0 in the ones place. So 10 in base 10, 10 here, ones place equals 10. However, in base 8, the highest number we have is 7. So assuming we had 7 in the ones place, this is the 8th place, so we add 1 to 7, there's going to be a 1 in the 8th place, and a 0 in the ones place. So, what you need to know is that there are no 8s or 9s in base 8. Keep that in mind, because there's no one-digit representation of 10 in base 10. obviously, there's no one-digit representation of 8 or 9 in base 8. They don't exist. So when you play the game, 8s and 9s are not allowed. If someone puts an 8 or 9 in the goal, or 8 and 9 required, it's an instant challenge impossible. It can lead to some pretty fun solutions. Like where if I put 8 or 9 are not allowed to be used in your solution, in the goal, or is required during gameplay. If you want to trick people, you can put them in permitted, which may cause them to challenge when they're not allowed to, which is really funny. Otherwise, you can use it to get smaller numbers. And now we're going to start explaining the other bases because we're only talking about base 8. So our next base, you're like, well, we have smaller bases, but what about a bigger base? Well, we're going to learn about base 12. Base 12 has 12 numbers in it. It goes from 0 to 11, and when we have something like this, we'll have base 0 will have the 1's place, base 1 the 12's place, 144th place, and now we see these all get bigger. So a 10 in base 12 is going to equal 12. Now that's very important because that means our numbers are going to get bigger, as we said before. So to keep in mind, bases below 10 will keep numbers smaller. Bases above 10 will make two-digit numbers bigger. Another thing to keep in mind, we just added 2 new numbers to our number system. What is the one-digit numerical value of 11, and what's the numerical value for 10? I don't know that. Well, they added 2 new numbers that you can use instead. In base 12, you can set the power as a 10, or the power with a star. That can equal 10 in base 12. And they added the square root can equal 11 in base 12. Keep in mind, these are the one-digit values of 10 and 11, so you can have something like 0 power, and this will be a 10. Well, it's the 1's place. It's a 10 in the 1's place, and a 0 in the 12's place. This equals 10. Same thing with the square root. Also to keep in mind, if you set something like power 0, you're going to have 10 times 12 is going to equal 120. Another thing to keep in mind, during goal setting, you are not allowed to make forced interpretations of powers or roots as sideways or upside down, because it's just illegal in the rulebook. Don't do that. So, the most important thing to keep in mind, BaseM only applies to 2 cube things. So, if I have a cube, let's say it sets a goal, cube 2, cube 3, and it's base 8. Well, what do? He sets the goal as 23. I have to convert that in base 8. So it's going to be a 2 in the 8th place, and it's going to be a 3 in the 1's place. So 16 plus 3, 19. That equals 19. We're going to be solving for that. Just because it has a 9 there doesn't mean that we can't solve for it, because that number is now in base 10. So you convert and then you forget about the base. But a lot of people, they get tripped up because someone will set the goal as, oh, well, we're still using base 8. And they're going to set the goal as 7 times 3. And we all know 7 times 3 equals 21. But 21 is a 2-digit number. Do we have to convert that into base? No, because these 2 numbers are already... Oh! So good there.
It's basically you only convert any 2-digit numbers you see. If you don't see a 2-digit number explicitly, you don't convert anything. So that's basic expressions. And once you're done converting, after any operations, you don't convert it. So this 7 times 3 stays as 7 times 3 in base 8 in any other base that you use. But if you were to set the goal as 21, you would convert it, but not if they set the goal as 7 times 3.
Let me do
Another peculiar thing about in regular equations, you're not allowed to put 2-digit numbers in your solution, but they can be in your goal, which is quite nice. But when we call base, you can also have 2-digit numbers in your solution. So you could have some pretty funny solutions. Let's say some nerd sets the goal as like, base 12, he sets the goal as power. And then another nerd puts a power sign in required. And you're like, that's the goal, but let's say there's a 0 in resources. You can just tell us now because you can make two-digit numbers. So you can literally just write 0 power is equal to power. This is the ridiculousness of two-digit numbers in base. But also, just saying, if you do use a two-digit number, you have to conversion from base whatever to base 10 takes precedence over all other operations. You have to remember that when you're writing a solution in base whatever.